So there are actually three different calculations we can run for analysis and design of concrete. There's a 2D analysis and design, which just allows us to model frames. So if you like little subframes, if you like, here's a quick example. And then we can pick and choose which of those beam spans to design. There's also beam analysis and design, which is just the design only part of it. So if you already know the design forces, the moments and shears, you can run this calculation to check the cross section at multiple points. And the one I think most of you are going to get to use is the actual full beam analysis and design. And I'm just going to run through a quick introduction using our 3-span example. So this is the standard interface where we can look at the design forces and overview of all the design results. This is our kind of summary page. If you want to investigate the analysis or update the loading details and so on, we just move into the analysis view. This is already a preset example, so it's not one we've started from scratch, but I'll just make a few amendments here. Let's, for example, update the spans, and we'll see analysis view updates. We can come in here and adjust the cross-section, and we can have a different cross-section for each span if you wish to. There's lots of information here for loading, so there's plenty of flexibility for loading. Perhaps the most interesting part here is the load combination generator, where instead of having to work out all the combinations yourself now, you can choose your design code, select the basic combination expressions, and it will work out all the various combinations and their various load factors. And then when we look at our results, we can look at those analysis forces by load cases, by load combinations, and you can get a good feel of the analysis result before you move into the design. In this latest version, we've enhanced the output options, so there's a lot more flexibility now to give you exactly the sort of output you want. And then when we come back to our summary screen, we can see how well the analysis is doing. So those changes in this case have actually made my second span fail, and my little summary screen shows the fail in red, and it even highlights the diagram as well. So we can then move on and design that, and we'll look at the design of this beam. There's a few general design options we can set for this particular example. Quite a nice feature here is we can actually set out our bar arrangements. So rather than just doing cross-sectional checks, we're actually setting up our bar zones. And they can either be lapping zones or 3 separate zones. So you can actually do that both top and bottom to set up exactly the pattern of reinforcement you want. If you're not interested in the actual lapping and you just want just a simple reinforcement, you can specify single zones, and that makes it a lot quicker just to specify top bars and bottom bars. And I've just set that there so I can show you both examples. The next thing to talk about here is the redistribution. This is quite an enhancement from previous versions. The calculation now is automatically doing all our redistribution for us and showing us that information. So this is actually showing us the envelope for the redistribution. We can also view that on a combination by combination basis to see what's actually going into making up that redistribution pattern. This is the moment redistribution diagram. We can also do the same for shear. And what's actually happening on this one, we're specifying a maximum allowable, and it's automatically calculating everything else for us. If you want to be a bit more refined, you can use a user-defined information here and specify the percentage redistribution yourself, but I think most of you would just go for the calculated option. When we move on to look at the actual reinforcement itself, then this screen, the first time you see it, may look a little bit complex, and there's quite a lot going on here. So I just want to take a moment and actually show you how this works. And I think most people's initial reaction is, oh, that looks a bit busy, but once you understand exactly how it's working, it's actually very straightforward. So the first thing to look at here is we split it into 2 areas. We've got the reinforcement at the bottom here, and we have the sketch showing what's going on at the top. I'm just going to turn off some of the settings on the sketch. We'll look at that first. If I trim that down to the basics, what we've got here is the grey area is the capacity, and the green is the actual design forces. So as long as the grey encompasses all the green, the beam is passing. So we can see at the bottom here that the green sticks out below the grey, and we also have the area error for the design reinforcement. If we tweak the bars at the bottom to increase the area provided, the grey is now larger than the green. And we can see now that that particular section is passing. I've just turned on the zone lengths there, so we can actually see that the actual lengths these bars need to be provided across. And On the bottom we're actually very efficient, so we're only providing bars exactly where we need them. This grey is only just overlapping the green. If you look at the top area, we'll find we've actually got the bars perhaps spreading longer than they need to. We don't need to have a 1.5 metre zone there for the reinforcement we're providing. So what we could do there is we can actually reduce that zone length a bit. So I'm going to just say let's drop this from 25 to say 15% of the length, drop it to a 900 mil zone length. I'll do the same on the other side, and now we've got quite an efficient design. I'm not going to spend too much time amending the different bar diameters and to refine it even further, but the basic tip here is you can now do an interactive design by looking at the graphic and instantly seeing how well your beam is performing and how refined your design is. And what we've got there is the actual capacity provided by, for example, the 3 20mm bars. This 942 millimeters squared is giving us the capacity on that zone, and the green actually only suggests we need 598 millimeters squared. So we've still got the traditional area acquired versus area provided, but we actually see it in a much more interactive and graphical view. We're currently looking at the force diagrams here. What we can also do is we can change that view to look at the reinforcement itself, and we get a nice little sketch pop up showing the cross sections and the bar marks, if you like, a little simple sketch for the beam. We've currently only got one bar layer, but we also have the option to put multiple layers, both top and bottom, on a section by section basis. And we can also, if you wanted to, increase the beam section size or decrease it, or even change it to a different section shape on a span by span basis. We'll just move on and look at the shear for a moment. This is exactly the same kind of concept. We've got the sketch at the top showing us our capacities. In this particular example, we only really need minimum reinforcement, so we could actually reduce our zones a bit more. But if we actually wanted to increase our reinforcement at one end, we can just do that. It'll increase the capacity, and then we can look at our sketch again to show us the actual arrangement for the bars, where we've got closing up the gap of the reinforcement at one end, assuming there was some higher shear there. So you're getting the options in the bottom here to just change your bar provisions, but you're getting these active sketches at the top so you can actually visualize exactly what's going on. Let's go back to the previous span. We'll look at the moment again. This is our largest span. If we move on to span number 3, which is actually only 3 meters long, that actually falls within that option I set previously for shorter spans. So you can see here that I've only got to need to specify top bars and bottom bars. I don't actually need to specify all these different zones. So for a simple example, you just want to specify the bars on the top, bars at the bottom. You can do that now, and that's back to a more traditional design arrangement. So let's just tweak one of these bar sizes. I'm not going to worry too much about the actual efficiency of the design, but you can just see the same is true, but on a much simpler view there. So now I've come back to the design screen here. The new feature you'll see in lots of our new calculations is these little buttons here for adding notes. So anytime you see one of those buttons, you can add in a little user-defined note. So we can just add some text in here, and that will then appear in the right spot in our output. So you can add notes throughout your designs. If I just preview that output, we get a nice preview view now, and you can see at the top here that user note is going to appear in our final output. In fact, you can add notes for all the different checks and clauses within this particular design, so all those different items there could have a user-defined note. And you can also opt to exclude those checks if you wish to. So, for example, if I don't want to see that section details, I can include it or exclude it to refine the report to be exactly what I need. And you can do that on a span-by-span basis to sort of highlight the critical checks and ignore all the rest of it. Let's have a quick look at that output. So there we go, we've got our analysis results, all the detailed calculations as you'd expect from TEDS, and our nice little sketches are embedded in the calculation.